example number 2, we're going to solve the logarithmic equation by using the properties of equality. Means that when the log with the same base on each side, if those are the exact same, then what I'm taking the log of also must be equal. Okay, so 2x squared minus 6 then equals 4x. And so this is just a quadratic equation, right? So I can set it equal to 0. So 2x squared minus 4x minus 6 equals 0. And then I can factor out a 2, right? So I can divide each side by 2, or everything by 2. Even that side. Oh, maybe I should actually divide that by 2. And then I can try to factor or use quadratic formula. But what times what is 3 but subtracts 2? Well, that would be 3 and 1. And then this one needs to be negative, right? This one needs to be positive. So x minus 3, x plus 1 are my factors. And then I can just take the opposite of those or set those equal to 0 and solve for x. So x equals 3 because 3 minus 3 would be 0. And then negative 1 because negative 1 plus 1, 0. 0 times anything, 0. So those are my two answers. The only thing that I have to do because I'm working with logs is I need to plug those back in and check because I can never take the log of any base of 0, right? It's not possible. So therefore I need to check these to make sure it works. So if I plug in 3, I plug in 3 here, I get 9. 9 times 2 is 18. 18 minus 6, whatever, it doesn't really matter. But 12, as long as it's not 0 or negative, right? But when I plug in 3 here, it still works, right? Because that's just 12, and 12 does equal 12. So we're good there. Now let's take a look at plugging in negative 1. So when I plug in negative 1, that's squared, so that's 1, 2, and then minus 6 is a negative 4. I can't have a negative, so the negative 1 is called an extraneous solution or an extra answer, so that one doesn't work, but that one does. Okay, so there's example